All right, let's jump right into John Ousterhout's incredible book, A Philosophy of Software Design. Now, it's all built around this one really powerful idea that as a developer, your most important job isn't just to make code work. No, it's to fight a constant battle against this single, relentless enemy.
And to really get a handle on what that enemy is, first we have to meet one of its biggest allies. I'm talking about a character that I swear every developer knows, the tactical tornado. You know the one. The programmer who just pumps out code faster than anyone else, valuing speed above, well, pretty much everything.
So have you ever worked with someone like that? Or maybe you've been that person. Hey, no judgment. In the short term, these folks can look like absolute heroes, right? Especially in a startup where it's all about move fast and break things. But here's the catch. That whole approach, just focusing on getting something, anything working, it builds up this massive debt of messy, tangled code. And guess what? The whole team ends up having to pay for it down the line.
But here's where Ousterhout really turns things on their head. He argues that the programmer, the tactical tornado, isn't the real problem. Nope, they're just a symptom. The true enemy, the real villain of the story, is the mess they leave behind.
And that enemy has a name: complexity. Ousterhout's definition is super simple, but so on point. It's basically anything about the structure of your software that makes it hard to understand and hard to change. His whole philosophy is really just a battle plan for fighting this thing, because complexity is what makes software so expensive, so buggy, and so fragile.
So he breaks it all down into two main causes. First, you've got dependencies. This is when your code is all tangled up, like a giant knot of wires where you can't change one thing without accidentally yanking on three other things. Then there's obscurity. This is when important stuff just isn't obvious. You have to read through tons and tons of code just to make what should be a simple change. Sound familiar?
Okay, so how do we actually fight back against all this? Well, the first principle is this really powerful idea for how we should structure our code. It's simple: build deep.
And this comparison right here just nails the core idea. On one side, you have a shallow module. This is where you have a really complicated interface, but the functionality behind it is pretty simple. Think about a class with like a million public methods that don't actually do very much. It just adds to the mental overhead. But then you have the deep module. This is the goal. It gives you really powerful functionality, but it's hidden behind a super simple interface. It's all about hiding that complexity.
And here's the key takeaway from that. Ousterhout says it's way more important for a module to have a simple interface than a simple implementation. So you, as the module's creator, should be willing to put in a little extra work, maybe make the inside a bit more complex, if it means the people using your module get a radically simpler experience. That's the trade-off. That's how you really hide complexity.
All right, on to principle number 2. This one is all about tackling that other cause of complexity we talked about: obscurity. The goal here is just to make our code obvious, like so obvious that another developer can look at it and just get it, without having to spend hours figuring things out.
So how do we actually make our code obvious? Well, he points to 3 main things. First, and this is huge, choose good names. Seriously, he has a whole chapter just on naming things, because precise, meaningful names are one of your best weapons against confusion. Second, be consistent. Use the same patterns for similar things. That way, once someone learns one part of your code, they can understand other parts too. And third, write good comments.
Now, that point about comments, it's a bit controversial, because it flies directly in the face of a really popular idea, especially from the book Clean Code, where Robert C. Martin basically says that comments are a failure. The idea is, if you had to write a comment, it means your code wasn't clear enough on its own.
But Ousterhout completely disagrees. He argues that this idea that code can speak for itself is just wrong. Look, code can tell you what it's doing, sure, but it can almost never tell you why. It can't explain the design choices, the trade-offs you made, or the other approaches you tried that didn't work. For him, well-written comments aren't a failure at all. They're absolutely essential for fighting complexity.
Okay, so this whole philosophy, this war on complexity, it becomes even more important, like critically important, when you start thinking about the future of programming, specifically in the age of AI.
I mean, think about it. Ousterhout predicts that AI tools are just going to get better and better at writing all that low-level boilerplate code. The tactical stuff that takes up so much of our day. So what does that leave for us humans? It means that our ability to do high-level design, the strategic thinking, that skill is going to become more and more valuable. And that brings us to a final, pretty big question. As AI starts writing more and more of our code, who's going to teach it good design? If we, the human developers, don't master these principles, if we don't learn how to fight complexity, we might end up creating a future where the tactical tornadoes aren't just people. They're the very machines we've built to help us.